Welcome. Today we're going to be talking about differential equations. So, what exactly are differential equations? Basically, you can have a rate such as dy dx, right? You have you have a rate, and this is some slope of a function of y with respect to x. And so this function could just be something like x. It could be xy. It could be x squared y. It could be anything, but it's proportional to a rate. And to demonstrate something is proportional, and in a physics class, you would call this, you would just say, hey, this is proportional with an alpha symbol. But in calculus, we're gonna just use some constant k and say, hey, this is equal to some function. If this is f of x, which is x squared y, this is proportional to the rate using this proportionality constant k. Generally, these will be done as a function of time because when you integrate it, like you'll have like dx dt is equal to kx or something. So then, uh, what you can do is you can just solve for your original function and some starter values if given. And then you can have a function of x with time once you integrate it, which is very common with what you'll do in this unit. Alright, so we're going to do some very basic integration. We're not even going to do integration, we're just going to write out this differential equation. So we have the depth of the water h is changing at a rate proportional to the square root of the depth given at that time. So the square root of the depth, which is h. So we already know we're going to have a square root of the depth, which is h, and then it's going to be proportional to that. So that does not look like an h. H. There we go. And then it's going to be proportional, so we're going to slap our proportionality constant k in there. And then we're going to say the rate dh, let's try that again, dh dt. And so here is our differential equation. The height is changing at a rate that is proportional to the square root of the height. But here's this next part. We're going to try and solve for the specific function because we have this k and we want to find k, and we have enough information to do that. So the water is changing at a rate of 4 inches per minute. That means dh dt is equal to 4. So dh dt is equal to 4, which is going to be equal to, see, when the height of the water is 4 inches. Well, we still don't know k, but we know the height. And so that is 4. And now we can do some simple algebra here. We know that the square root of 4 is actually 2. So 4 is equal to 2k. Divide both sides by 2. 2 is equal to k. Now we can substitute this back into our equation up here. So for this function, dh dt is going to be equal to 2 times the square root of h. So now, if the problem said, all right, what about 8 inches? We could just substitute 8 in here, and then we would get our dh dt.